All right, everybody, welcome to Math with Grace. For this video, we're going to be working through Pre-Algebra, Book 806, Lessons 6 through 9. Lesson 6 begins on page 22, and it's about simplifying expressions with division bars, okay? When expressions are separated by a division bar, you must first simplify the numerator and the denominator separately, using the correct order of operations. Please don't forget your orders of operations, right? Then we want to reduce to our simplest form. Here's the key. We do not change improper fractions to mixed numbers. So see, this is 3/2. You don't need to write 1 1/2. 3/2 is a perfectly good answer, okay? So what they're doing basically is simplifying the numerator on its own, right? Multiplying first, then adding, and doing the same in the denominator, then reducing once they have a single term in both the numerator and the denominator, okay? So let's take a look at some of these problems. All right, looking at the first set of problems here in Lesson 6, Book 806, we're on pages 22 and 23. Problem number 1 is done for you, so I'm not going to go through that again, but let's take a look at problem number 2. Again, we need to simplify our numerator and our denominator separately. So taking a look at this, in the numerator, we have 6 minus 4 times 2 plus 5. Now, I know my multiplication needs to go first, so I'm going to put parentheses around it to make sure that I do that first. So that leaves me with 6 minus, what is 4 times 2? Well, 4 times 2 is 8, right? And then a plus 5 all over. Here's our denominator. Now we have a 9 times 4, multiplying comes before addition in our order of operations, plus 3. Well, 9 times 4 is 36 plus 3, right? So now we're left with only adding and subtracting. They have equal weight when we're talking about what should be done first, our orders of operations. So we can you can add your two positives together and then subtract your 8, or I just move from left to right. So 6 minus 8 is -2. -2 plus 5 is 3. 36 plus 3 is 39, right? But this can be reduced, and we know that because 3 goes into 39 evenly, so there's 1 3 and 3. And how many 3s are in 39? Well, there are 13. So our final answer is 1/13. All right, let's take a look at number 3. For number 3, we have 8 plus 6 times 5. Immediately, my multiplication, I'm going to put parentheses around. In the denominator, we have 3 times 3 times 4. Now, when everything's just being multiplied, it does not matter what order you multiply them in. That's our commutative property of multiplication. So we don't need to do one over the other. They can all be multiplied in whatever order you want as long as they're all included, right? But let's focus on our numerator for now. In our numerator, we still have our 8 plus our 6 times 5. Well, 6 times 5 is 30, right? And then in our denominator, again, we have 3 times 3 times 4. Well, 3 times 3 is 9 times 4 is 36. So now we can add our numerator together, right? So we have 38 over 36, but this can be reduced, right? What number goes into 38 and 36 evenly? Well, they're both even numbers, so that number is going to be 2 at the very least. How many 2s are in 38? Well, there's 1, 2, and 3, and it has a remainder of 1, and there are 9 2s and 18, right? And what about 36? Well, again, there's 1, 2, and 3 with a remainder of 1, and there are 8 2s and 16. So our answer for this one is 19/18, and we're going to just leave it like that. We don't want to write 1 1/18. This is the answer form that we're looking for. Let's take a look at some more. So the next problem I want to look at is problem 4. In our numerator, we have 3 times 4 plus 2 times 3. In this case, we have 2 sets of multiplication, so I'm going to make 2 sets of parentheses. In our denominator, we have 9 minus 4 times 3. Again, my multiplication goes first, so I'm going to put parentheses. 3 times 4 is 12. Don't forget your plus there in the middle. 2 times 3 is 6, right? All over 9 minus 4 times 3, or 12. So 12 plus 6 is 18, all over 9 minus 12, which gives us a -3. Now, This can be reduced, right? 3, even though it's negative, goes into 18 evenly. How many 3s are in 18? There are 6. A positive number divided by a negative number gives us a negative answer. So this one reduces to a whole number of -6. Okay, let's look at number 5. In 5, we have 7 minus 5 times 2. Well, our multiplication comes before subtraction, right? In our denominator, we have 2 times 3 minus 1. Again, multiplication comes first. Don't forget your order of operations, right? Please excuse my dear Aunt Sally. All right, this is parentheses. This is exponents, right? Multiplication and division. Although they hold the same weight, you can do both of these at, you don't have to do the multiplication before the division. And then these hold the same weight as addition and subtraction. Okay, please excuse my dear Aunt Sally. PEMDAS. All right, number 5, let's get back to it. We have 7 minus 5 times 2, or 10, all over 2 times 3, which is 6 minus 1. Now we can combine our like terms, right? We can do our subtraction here. We've got 7 minus 10, or a -3, and we have 6 minus 1, or 5. And that's it. Our answer is -3/5. That can't be reduced any farther. Now, there's one more problem, number 6, I'm not going to do here on this video. I'm going to leave that for you to try out on your own. But remember, we want to follow our order of operations, working on the numerator separately, then the denominator separately, until we have one term in both the numerator and the denominator. At that point, we need to reduce if possible, or just mark it as our answer. That's lesson 6. Lesson 7 begins on the bottom of page 26, and it's about using percent proportions to solve story problems. Now, the percent proportion is this. It's is over of equals the percent over 100. Now, that's how the book is setting this up, but I want us to do these problems different. This percent proportion, while it can be useful, causes a lot of problems for some students in understanding exactly what they're doing. So if we look at the examples, they've done each example in the percent proportion way. But what I want us to do is we're going to do this in the Mrs. Howell way, which in your life should make things a whole lot easier. And here's what we need to know, though. The word is, and we've studied these before, is the same as equals. Okay? The word of is the same as multiplication. When you see the word of in a math problem, a story problem, it means multiplication. When you see the word is, it means equals. And that's how we're going to solve these, okay? So let's look at this first example. Colleen added $1.25 markup per yard to a bolt of fabric that cost her $4.50 per yard. The markup was what percent of the cost to Colleen? Okay, the markup, was is just the past tense of is, right? So the markup was, and this is how I mark all my story problems, was is the same as the equals, right? Markup was or equals what percent, we don't know what percent, so that's our x. Of, right, this is multiplication. I'm going to use a dot since I put an x there. So let's change it up here. This is, I'm going to put a dot, and this is multiplication. Multiplication. Spelling is not my best subject. Okay, what percent of the cost to Colleen? All right, there is our setup, okay? So the markup, which is $1.25, was or is what percent, we don't know, of the cost. Her cost was $4.50. Now, if we simply solve for x here, we'll see that we have to divide both sides by $4.50 so that x is equal to 1.25 divided by $4.50, right? And if we just do that on our calculator, we find out that x is equal to 0.27777. It repeats, okay? Now, is this a percentage? No, right? We have to change this now into a percentage, and that's where this 100 comes in their percent proportions, because you just multiply it by 100. But you guys are clever, and you know you just have to move the decimal 2 places, right? They want it rounded to the nearest whole percent, so they rounded it to 28%. Okay, 7 changes that 7. This setup to me will help you not just in percentage problems going forward, but in story problems in general, okay? This is very much a exchanging words for symbols for story problems. And so I don't necessarily see the advantage to using the percent proportion when we can just use our story problem skills. All right, let's take a look at the next example. Colleen spends about 14% of her time in the store doing routine bookkeeping. She spends 5 hours on bookkeeping this week. What was the total time she spent in the store this week? So 14% of her time is spent doing routine bookkeeping, right? Well, 5 hours is that 14%. So 5 hours, see, this time it's not written out like this, right? We have to kind of read the story problem and figure it out. 5 hours is 14% of what time? How much time? Well, we don't know, right? That's the question that we have. We don't know what her basic time was. We just know that it's 14% of her time is spent doing bookkeeping. Well, that 14% is 5 hours. So now we have to figure it out. In this case, we have to change our 14% into a decimal so that we can use it in a story problem, right? So 5 hours is equal to, how do we write 14% as a decimal so that we can use it here? We move our decimal 2 places, right? So it's 0.14 times x. Well, just like before, x is being multiplied by 0.14, we're going to do the opposite and divide. And so the x is equal to 5 divided by 0.14. Putting that into our calculator, our answer comes out as 35.7, and a whole bunch of other numbers I'm not including because that's enough. They want us to round, and so she's been at the store 36 hours. 14% of that she spent on bookkeeping, which was the 5 hours, okay? But this is the total amount of time she spent at the store. All right, let's take a look at the last example here, and then we'll do some of the problems with the homework, all right? After Frida had 12 weeks of physiotherapy, the doctor told her she had regained 30% of the strength in her left arm. If Frida could lift a 20-pound weight with her left arm before her stroke, how much weight can she lift with it now? Well, she can only lift 30%, right? So what is, right? We don't know. 30% of 20 pounds. She can only lift 30% of what she could before, of what she could. You got to recognize those ofs. Ofs mean multiplication, right? 30% of is what number? How much can she lift now? We don't know. How much can she lift now is equal to 30% of what she used to lift, which was 20 pounds. Now, we need to change our 30% to a decimal so that we can use it in this equation. We do that by moving our decimal point 2 places. So we have 0.3. We can leave off the last 0. Times 20, right? And putting that into our calculator, we get the even number of 6. And so now she can lift 6 pounds, which is 30% of 20 pounds, okay? Doing it this way allows us to practice our story problem skills, because in your math career looking forward, story problems aren't going anywhere. This percent proportion is okay. Go ahead and compare it to what we're doing if you'd like. It's just, it slips up with some people and they have a hard time putting it into these percent proportions, where if we just read our story problem, we can verbally put things into the right order. Okay, let's take a look at some of the problems. All right, so we're going to look at number 1 on page 26, and it reads, a minister's wife purchased a pair of pinking shears that originally cost $39.75. If you don't know what pinking shears are, I guess you can look it up. It really necessarily doesn't matter, okay? This is extra information that they're trying to confuse you with. But their cost was $39.75. Due to the discount for ministers' families and the scissors being on sale, she paid only $34.55. What percent of the regular price was this? Okay, we don't know the percent, right? So that becomes our X. Here's our of. The regular price was $39.75. And what was is equals this. And that's this, this is what she paid. So let's write that out. What percent, we don't know, of the regular price, which was $39.75, is this, which is the price that she paid, $34.55. All right, there, that's it. We did it. We didn't have to set up proportions. That's it. We did it, okay? What percent of the regular price was the price that she paid? Or this is what they used, right? Pronouns. So X is being multiplied by $39.75. So we're going to do the opposite and divide, right? $39.75. So doing this on our calculator, we see that X is equal to 0.8691, I don't know, 824, right? It just goes on and on. Okay, we're looking for a percent though. What percent? Well, this is our percentage, right? But it's written out as a decimal, so we need to change that. So we're moving our decimal 2 places to the right, and then we're going to round because they want to round it to the nearest whole percent. So we're going to round our 6 based on our 9. Because our 9 is greater than 5, it's going to bump our 6 up. So our percentage becomes 87%. All right? What percent of the regular price was this? She paid 87% of the regular price. Now, looking at that, it's kind of weird because we don't normally talk about what percent of the regular price she paid, right? We usually talk about the percent that she saved, that she got a discount on. And you could figure that to be the 13% because that's what it is. She saved 13%. All right, but that's not technically what they're asking you. She paid 87% of the regular price. Let's do number 2. All right, number 2 reads, the markup on Tropical Breeze fabric was $1 per yard, or 15% of the price Colleen pays for it. What price does Colleen charge the customer per yard for Tropical Breeze fabric? Okay, so the $1 is 15% of the price Colleen pays that we don't know, right? So $1 is 15% of the price Colleen pays, which we don't know. Now, they're asking us what price does Colleen charge the customer. All right, we first have to know what she pays before we know what she charges the customer. So this problem is more of a 2-step problem. We have to solve for what Colleen pays and then add our dollar. Okay, and that's what we're doing here. Let's rewrite this as a decimal percentage, right? We move our decimal 2 places, so it's 0.15 times X. 0.15 is being multiplied by X, so we're going to do the opposite and divide. I'm going to move over here because I'm falling off the edge of my book here. So we have that X is equal to 1 divided by 0.15, or $6, or 6.666, and it really just goes on and on. Okay. Now, they want us to give our answer to the nearest cent, but we don't have the answer yet. What price does Colleen charge the customer per yard? Well, she pays, that's what we just figured out, $6.67, right? Let's say 6.67, we round. But what does she charge her customers? She marks it up $1. So now we need to add that $1, and we see that she charges her customers $7.67. Okay, so this was a 2-step problem. First, we had, because they gave us the information that regarded to what Colleen pays. So that's the only thing we could have solved for, is what she pays for her fabric, which was $6.67. but they're asking what she charges her customers. Well, we know she charges her customers $1 more per yard. So we just added $1 to what she paid. Now, like I said, feel free if you looked at the percent proportions and that makes a lot of sense to you. I'm not going to mark it off if you use percent proportions. I would rather teach it this way though, because I know as we move forward with story problems, being able to decipher what's going on in the story problem in this manner and write out an equation is going to benefit you in the long run. All right. This is lesson 7. Good job. Lesson 8 begins on page 31 and it's combination probabilities. And what that means is that sometimes in probabilities, there will be more than one kind of favorable outcome. And we recognize that with the word or, all right? Now, I'm not going to read this whole problem. You can see that Grandma's got a button jar holding all different colored buttons, right? Rachel wants a yellow or a tan button. So she would like either. If she got a yellow, she'd be happy. If she got a tan, she'd be happy. She wants either button. So how do we set these up? Well, the same way we do probabilities any other time. We need to know the total number of outcomes. So we add up the different quantities of buttons that are available, and they get 52. Then we want to know the number of favorable outcomes. Well, she would like a yellow or a tan, so we add those together, and now we have 17 favorable outcomes. Remember, favorable over our total number of outcomes, right? We want favorable over total, all right? So they put the 17 over the 52 and just divide it to find their percent. Divide, multiply by 100, or just move your decimal, okay? So looking at number 1, here on the bottom of page 31, we read that in the board game you are playing, you would like a 1 or a 6 in your next roll of the die. What is the probability? Well, how many outcomes are there? Well, on a die, you know there are only 6 outcomes, right? So that is our total. It goes in our denominator. And how many favorable outcomes are there? Well, you would like a 1 or a 6. So that's 2. So the ratio is 2/6, but we need to reduce that to 1/3. Okay, so your ratio is 1/3. And what percentage is that? Well, we should recognize that 1/3 is 33 1/3%, right? From our practicing of recognizing percentages. 1/3 is 33 1/3%. So you have a 33 1/3% of rolling a 1 or a 6 on your next turn. Let's flip the page and do the next few problems. All right, so looking at page 32 of lesson 8, we've got several things here. And it says the numbers 1 through 25 are written on slips of paper and placed into a hat for determining the order of a gift exchange. What is the probability of drawing? Well, we have the numbers 1 through 25. So how many total options are there? Total outcomes? Well, there are 25, right? 1 through 25. So what is the probability of rolling a 1? Well, a 1 is just one number, so it's 1 out of 25. Changing that over into a percentage, we just divide 1 by 25, and we get that it is a 4% chance. You have a 4% chance of rolling a 1 or drawing a 1, okay? 1 divided by 25 looks like this, right? And you get 0.4 or 0.04. If you did the long division, or if you do it on your calculator, it would be 0.04. That's the decimal percentage. To change it to a percent, we move our decimal 2 places, and it looks like that, okay? Number 3 asks us, what is your probability percentage of drawing a 1 or a 2? Well, again, our total options or outcomes are 25. But this time we want to draw a 1 or a 2. Well, we've got one chance to draw 1 and one chance to draw a 2. We add those together and we get a 2. Now, we're going to divide this just like we did the last one. Okay, 2 divided by 25 is 0.08 is what it works out to be. Put it in your calculator and that's fine. You move your decimal 2 places, so we know that we have an 8% chance of drawing a 1 or a 2, which makes sense, right? Because drawing one specific number, we had a 4% chance. So drawing two specific numbers, having an 8% chance makes a lot of sense. Now, for number 4, they're talking about an even number. Well, our total outcomes has not changed. We still have 25 total outcomes. But how many even numbers are in there? Well, how many 2's, right? 2 is our even number. How many 2's are in 25? Well, there's 1, 2, and 2, right? And there's 2 2's and 5. 2 2's is 4. We don't need to worry about the extra, but we know there are 12 even numbers in 25. If you counted 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 12 numbers, okay? Now, again, percentage. Put it into your calculator. Put it into your calculator, you get 0.48, right? We move our decimal 2 places, and we know then that we have a 48% chance, which is, right, it's either as likely as not likely, pretty much, of drawing an even number. Now, let's take a look at the next 2 problems. Now, in my opinion, number 5 is the dumbest question in this book. But they want to know, what is the probability of drawing an even or an odd number? Well, we still have 25 total outcomes, and if we're drawing either an even or an odd, that includes every number in there. So your favorable outcomes are 25, and so it is a 100% chance that you will draw an even or an odd number. Okay, that's all of them are either an even or an odd. There's not a third kind of number, so it includes all of our outcomes. So I hate that question. Number 6 asks us, any number between 1 and 5, any of the first 5 numbers. Well, still, we've got 25 our total outcomes, but what are our favorable outcomes? Well, it's anything between 1 and 5. Well, that's a 1 and a 2 and a 3 and a 4 and a 5, right? We add those together and we have 5 favorable outcomes. Now this can be reduced to 1/5, right? That is our ratio. So what is our percentage? Well, 1 divided by 5 is 0.20, right? And that transfers, when we're talking about percentages, to a 20% chance. You have a 20% chance of getting a 1 through a 5. All right, so when we're working with these, we want to make sure, because they're combination probabilities, that we add up all of our favorable outcomes. Sometimes we would like more than one thing. You know, like the girl who wanted a yellow or a tan button. We had to add those 2 options together to get our total favorable outcomes. Our total outcomes don't change, but our favorable outcomes change. Then we just divide and switch it over to a percentage. Lesson 8. All right, lesson 9 begins on page 36, and it's all about line graphs. Now, a line graph shows how a value changes over time, okay? Here's the monetary, or the kilowatts is what they're dealing with here, and then here's our time in months. All right, so it shows how things change over time. All right, the line on the line graph always moves from left to right across the graph according to the time scale shown on the bottom of the graph. So let's take a look at our example graph here. We've got our electric usage through the year, right, through this year. And so they just marked it with a J for January, February, March. You know, they just put the first letter of the months here. And then they have the kilowatts used. Now, we're going to go through this list here of ways to set this up. And we're going to do it with problem number 1. Now, I've already finished problem number 1, but we'll go through it together anyway. So the first step in drawing your line graph is to determine the minimum and maximum amounts. So you want to look through your sales for this one, right? And see which is our maximum and what is our minimum. So here we've got 4,355, right? At first glance, that looks like our largest number. So let's just double check. It is, right? So we definitely need to have our graph go up to at least 4,400, right? We want it to be slightly higher. Now they started our values here at the bottom. So we can look at, well, how did they write these? They started at 2,600 and then they went up by 200, skipping a line. So this is 27, 28, 29, 3,000, 3,100, 3,200, 3,300. So then I wrote 3,400. This would be 3,500, 3,600, 3,700, 3,800, 3,900, 4,000, 4,100, 4,200, 4,300, which gets us close to this, and then 4,400 because we want to go slightly over, okay? Remember, you want to be slightly more and slightly less. That's why they started us at 26, because it looks like our lowest one is right here at 28 something, okay? So you want to be able to go slightly over and slightly under. Now, you want to determine what numbering sequence. Here, their numbering sequence was by the hundreds, right? Every line represents $100. Now, they only marked every other line, but that's fine, because by marking every other line, we can determine that their sequence is $100, all right? Now, here's the thing. You want to start lower than the lowest and end higher than the highest. They started lower than the lowest. We went higher than the highest, all right? We want to center each item on its line. So now when we mark our time here, again, we're doing time in months, but that's not always how. Sometimes it's years or decades even. But we want our time to be on a line, not like a box graph where our time takes up the whole section. We want our time to be on our line. So January was where we're beginning. It's on this line. So the dot that I put for January will be on that line. All right. And then we plot a point for each individual piece of data. So for January, our sales were 4,120. Now, I know that 4,100 is this line here, this horizontal line, but I've got a little bit more than that, so I just have to estimate, and I put my dot there. Then I went to February, and February is 3,885. Well, here's my 3,800, and again, I have to estimate where in this block here, where in this section, 885 would be, right? Or sorry, not 885, just 85. Well, each section is 100, so I put my dot a little bit closer to the top. Then I went to March and did my 3,970 and so on. Once I was done putting the dots on, all right, these I'm just putting dots on, then I went back and I connected the points from left to right. So here to here to here, 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 you know, it's like connect the dots like you played when you were a little kid, right? And then you have to give your graph a title, which I didn't actually do, but it would just be fabric sales, right? Because that's what this title is right here, right? So that's the title of my graph. Here are our fabric sales. If you were putting them together a presentation, you could throw that up on the wall and see that, wow, we really tanked in April. It's very visual representation of what is happening in their fabric sales. All right. So that's the basics of line graphs and statistics. Fairly straightforward, not anything we haven't really done before. So they only had the one example or the one problem to work through. And now we've got through it. All right, so that's lesson 9. If you have any questions coming up for the week, you know how to reach me via text or during my office hours. Otherwise, until next time.